Today we're learning from 4.3 right triangle trigonometry. So just as a heads up, we're splitting 4.3 into two halves. So after 4.3a, we're actually going into 4.4, then 4.2, then 4.3b, then we're going in order as 4.5, 4.6, 4.7. And I'm doing it this way because I think it'll be easier for you to understand that it flows better in this order. Here's what you need to be able to do after this lesson. Evaluate the 6 trig functions of acute angles. Remember, acute angles are angles that are between 0 degrees and 90 degrees. Right? If you're given real life problems, basically word problems, you need to be able to model them using trig functions and then solve them. Also be able to use a calculator to evaluate trig functions. Alright, let's take a look at a right triangle here. Right? If we have a right triangle, and let's call this angle theta. Oftentimes it's also represented as a capital A, capital B, that type of a thing. From this angle's point of view, notice that we have an opposite side and an adjacent side. Right? Adjacent meaning the one right next to it. And then the longest side across from the 90-degree angle, this corner here, is always the hypotenuse. Hypotenuse. So we're looking at the word trigonometry. Trigonometry. And it means the measurement of triangles. It's from a Greek word, or the Greek roots tell us that it's a measurement of triangles. Specifically today, we want to take a look at the ratios, the ratios of the side lengths. So if I'm standing at this angle here, this acute angle, notice that I can have adjacent to opposite. I can put opposite over adjacent. I can have hypotenuse over adjacent or adjacent to hypotenuse. I can have opposite to hypotenuse, hypotenuse to opposite. Notice that those are the 6 different types of ratios or relationships that it can have. And these ratios, right, we give them special names. So remember, ratios are, you can have like fractions. Let's say if we have, 3 to 2, 3 boys to 2 girls, or 3 to 2, right? Ratios are when we compare 2 values. We're comparing the lengths of 2 sides of a right triangle. So for each of these ratios that are possible, we give them names. Do you guys remember the little saying? Soka toa, right? So if we're comparing the opposite side of a triangle, of a right triangle, to the hypotenuse, if we compare those 2 lengths of a triangle, we call that ratio the sine ratio, right? The sine ratio. So we say sine of angle theta, right? Sine of angle theta is opposite over hypotenuse. So sine theta equals opposite over hypotenuse, meaning if you stand at the angle theta, right, on a right triangle, if you stand here and you look at the opposite side length and put it over the hypotenuse side length, that ratio, we call that ratio a name, and that's called sine, right? Sine is the name of that ratio. Okay, we also have a name for the ratio where you have adjacent side over hypotenuse. So if I have adjacent, right, over the hypotenuse length, if I put those 2 numbers as a ratio, as a fraction, that is called the cosine ratio. And the abbreviation for that is COS, right, cosine theta. So if you stand at that angle theta, you take the cosine of that, meaning by definition, you take the adjacent over hypotenuse, we get the following relationship. Cosine theta equals adjacent over hypotenuse. I hope you remember T is for tangent, right? So tangent theta equals opposite over adjacent. So soka toa. And remember, we can also flip them over, so we can have their reciprocals. So instead of O over H, if I had H over O, that is called, do you guys remember? Cosecant theta. Cosecant ratio. Again, it's just a special name that we give to the ratios. If we flip the cosine one over, if I put hypotenuse over adjacent instead of adjacent over hypotenuse, that is called secant theta. Secant. Notice that the first 3 letters For secant, give you the abbreviation. For cosecant, it's every other letter, C, S, C, cosecant theta. And then for tangent theta, the reciprocal of opposite over adjacent, right, is cotangent theta, cotangent, and these are the first three letters, right, that are the abbreviation for cotangent. Note that there are three trig functions that start with a letter C. So you want to be careful that you don't get them mixed up, right? Cosine theta, cosecant theta, cotangent theta. So cotangent theta is kind of easy to remember because that goes with tangent theta, right? Cotangent, tangent, they sound similar. Okay, so cosine theta and secant theta, you want to remember that. Sine theta and cosecant theta. So just remember that sine, the S goes with C, and then the C goes with S for the reciprocals. Here's another thing I want you to notice that'll come into play in the future. Notice that sine theta is opposite over hypotenuse. What if I put 1 over sine theta? That would be 1 over opposite over hypotenuse, which is 1 times the reciprocal. So notice that you get hypotenuse over opposite, right? So if you do 1 over sine theta, that is equivalent to cosecant theta. So 1 over sine theta is equal to cosecant theta. So secant theta is equal to 1 over cosine theta. And cotangent theta is equivalent to 1 over tangent theta. Right? If you put 1 over something, it'll give you the reciprocal. Before we look at an example, recall that if I have a right triangle with side lengths A, B, and the hypotenuse C, a squared plus b squared equals c squared by the Pythagorean theorem. Let's take a look at an example. It says find the exact value of the 6 trig functions of theta. And if I give you a right triangle here, give you theta here, and tell you that this is 2 and this is 4. So again, right away, we were only given 2 of the 3 sides, but we can use Pythagorean theorem to find the third side. So 2 squared plus something squared is equal to 4 squared. So x equals plus or minus square root of 12, but in this case, since it's a side length, it's only going to be positive. We, simplify that, getting 2 root 3. So 2 root 3 is the side length right here. So let's find all 6 trig functions. So we're looking for sine theta, cosine theta, tangent theta, and their reciprocals, right? S goes with C, cosecant theta. C goes with S, secant theta. And cotangent theta goes with the tangent theta. Recalling SOHCAHTOA, let's go ahead and put the ratios down here. Sine theta is opposite over hypotenuse, so opposite is 2 over hypotenuse is 4. We go ahead and reduce that, we get 1/2. Cosine theta is adjacent over hypotenuse, so adjacent over hypotenuse, 2 root 3 over 4, which is root 3 over 2. Tangent theta is opposite over adjacent, so opposite is 2 over adjacent is 2 root 3. These cancel out, giving me a 1 over 1 root 3. When we rationalize the denominator, multiply by a form of 1, getting root 3 over 3. Okay. Looking at cosecant theta, the easiest way would be to flip over the sine theta ratio. So 2 over 1, which is just 2, since it's the reciprocal. Secant theta, again, we can take the reciprocal of the cosine function, since that's how they're related, they're reciprocals of each other. We can write down 2 over root 3. Again, we need to rationalize the denominator, so we get 2 root 3 over 3. For cotangent theta, I could take my tangent theta and take the reciprocal, but notice that I originally had 1 over root 3 before I rationalize. So if I just flip over 1 over root 3, that would give me root 3 over 1, and I wouldn't need to go that extra step. So again, it's still fine if you wanted to take the reciprocal of your final answer here and then rationalize. It's just more work is all, but you get the same exact answer. Okay, let's have you try a U-try. Here's a right triangle given to you. Find the exact values of the 6 trig functions of theta. If you're using Edpuzzle, I'm going to have you find the answer to cosecant theta. All right, here are the correct solutions. Let's take a look at special right triangles. Special right triangles. Okay, if I were to have a square, let's make the lengths 1 by 1. Okay. If I had that, and if I cut the diagonal, right? If I cut the diagonal, I would end up with a right triangle, one of my special right triangles, where it's 45, 45, 90. Notice that my side lengths here would still be 1, 1. And if I were to use Pythagorean theorem, right, 1 squared plus 1 squared equals c squared, I would end up with the hypotenuse equaling square root of 2. So I get a 1 root 2 ratio. We want to remember this special right triangle here, the 45, 45, 90. Now imagine we have an equiangular or equilateral triangle. So all the side lengths are equal, and it's 60, 60, 60 degrees. Let's make the side lengths 2 units, like 2 centimeters, 2 meters, 2 inches. It could be anything. Let's say if I were to fold it in half or cut it in half, okay, what kind of triangle would I get here? Right, it would be a right triangle here, that's a 2. Since I split it in half, that's going to be 1 unit down here. Again, if I were to use Pythagorean theorem, 1 squared plus x squared equals 2 squared, I would end up with that length equaling root 3. So I get a 1, 2, root 3 triangle. Notice this corner was 60 degrees. Therefore, this 60 degrees cut in half would be 30 degrees. So I get a 30, 60, 90 right triangle. Now, here's a little way to remember the side lengths or the ratios. 30 degrees, 60 degrees, and 90 degrees. Remember, 30 degrees is the smallest angle. So across from that angle is going to be the smallest side, or 1. So baby, right, baby eats 1 serving. So between 60 and 90 degrees is like the biggest, so that's dad. Daddy eats 2 servings of food. And then 60 degrees, the one that's in the middle, is the mom. Mom is vegetarian, so she eats the root, right? She eats the square root of 3. So again, baby eats 1 serving, dad eats 2 servings, mom is vegetarian, eating the square root. So here are the types of examples you need to be able to do. Find sine of pi over 6. Remember, pi radian is 180 degrees, so 180 divided by 6 is 30 degrees, meaning this is equivalent to sine of 30 degrees. So find sine of 30 degrees. That means what is the ratio opposite, right? So, right, opposite over hypotenuse when you are at angle 30 degrees. So at 30 degrees, opposite over hypotenuse is 1 over 2. That is your ratio. 1 over 2, or 0.5, right? That is your final answer. So you need to be able to do for all 6 trig functions, and for 30 degrees, right, 45 degrees, and 60 degrees. So 30 degrees, that's equivalent to pi over 6, 45 degrees, pi over 4, 60 degrees, pi over 3. Remember, if I have a 1/6 of a slice, that's a smaller angle, so that's 30 degrees, versus if you have a 1/3 of a pi, right, that's 60 degrees. Here's how you try. Find the exact value of cosine of pi over 4. Okay, correct answer is square root of 2 over 2. Note that here, because both of these acute angles are 45 degrees, it doesn't matter which angle you picked, you would still get the same answer. Okay, let's have you try another one. Find the exact value of tangent of pi over 3. Okay, correct answer is square root of 3. Notice that you would need to draw out the right triangle and stand at 60 degrees and do opposite over adjacent from that reference point. So I recommend that if you're doing your homework or taking a test, that you just draw out the 2 special right triangles on a separate sheet of paper or on the top of the page, and then refer back to that. That way you're not having to constantly draw out these triangles for every single problem. I have a separate video that shows you a shortcut way of finding these ratios. So take a look at that if you'd like. It's called a left-hand trick. The left-hand trick. Okay, in your calculators, On the top left corner, you should see a button that says Mode. If you press that Mode button, on the third row, you'll have an option of clicking radian or degree. So what you're highlight that, right? Have it highlighted and hit Enter to go between the two modes. This is telling your calculator what unit you want to be in. When you're talking about angle measure, are you telling your calculator to be in radian or degree? Here's an example. If I ask you to find cosine of 20 degrees, and let's have you round to the nearest thousandth. Okay, nearest thousandth, so 3 decimal places. Notice that you have that degree symbol, so you need to be in degree mode. Press cosine of 20 degrees, hit Enter, and we should get 0.940 when rounded to the nearest thousandth. Okay, go ahead and try this. You try. Find tangent of 2 pi over 5 rounding to the nearest thousandth. Okay, correct answer is 3.078. Note that you need to be in radian mode for this problem because your angle measure is in radian. I know it's in radian because I don't see that degree symbol. What if I ask you to find secant of 40 degrees? Okay, I see that degree symbol, so I know we're in degree mode. But there is no secant button. So secant, cosecant, cotangent don't have their own special buttons. So the way we need to do this is use that reciprocal relationship. So remember, secant has to do with, right, if it's S, it has to do with the one that starts with a C. Cosine, but it's reciprocal. So 1 over cosine of 40 degrees is what we need to plug into our calculator, giving us 1.305. Let's have you try this problem. Find cosecant of 13 rounding to the nearest thousandth. The correct answer is 2.380. Make sure you are in radian mode because you don't see that degree symbol. And cosecant, it's the one that starts with C, therefore it has to do with sine. You have to put it as reciprocal, so 1 over sine of 13. Let's take a look at angle of elevation and depression. So angle of elevation is when you're looking upward. So let's say you're here and you're looking up at the star. So angle of elevation is the angle created between the horizontal looking upward to the star. So this angle right here is the angle of elevation. Angle of depression is when you're looking downward. Let's say you're looking at a little flower. Angle of depression is the angle created between the horizontal, it's always the horizontal, never the vertical, looking downward to your thing, to your object. So this angle right here created from the horizontal looking downward is the angle of depression. Here's an example. A skateboard ramp is 4 feet off the ground with an angle of elevation of 18.4 degrees. What is the length of the ramp? So we have a skateboard ramp here, and it's 4 feet off the ground. It says with an angle of elevation of 18.4 degrees. What is the length of the ramp? So this is the ramp, so that length is what we're looking for. We'll call it x. So notice that we have 3 parts to this right triangle, and how can we relate them? Let's take a look. Standing at this angle, we have the opposite and the hypotenuse. So when you have opposite and hypotenuse, that's going to be the sine relationship. So sine theta, but in this case that theta angle is 18.4 degrees, is equal to opposite over hypotenuse. Okay, go ahead and try this problem. Find the length of the ramp rounding to 2 decimal places. So here you have to be really careful. You were trying to get the x by itself in the numerator. Right now it's in the denominator. So if you multiply by x on both sides, I get x sine of 18.4 degrees is equal to 4. And divide by sine of 18.4 degrees so that I can get that x in the numerator. So x is equal to 4 over sine of 18.4 degrees. Make sure you're in degree mode, and we would get 12.67 feet as our final answer.